Alright, scholars, for today's notes, we're going to try something a little different. In fact, we're not actually going to really take notes at all. You will still need a piece of line paper. Blank paper will work too, actually. I will say, though, if it's part of your notebook, it's not going to work because you are going to take this paper and you are going to probably only use about half of it. Either way, you're going to be doing some ripping and some cutting and some tearing and, that sort of thing. So, do not do this in your notebook, please. Now, I'm going to write a couple things down just for reference. You do not have to copy this. You certainly can. And this part, I guess, could probably go in your notes if you wanted, but it's not necessary. Okay. Real fast, we're just going to go over some of the things we talked about yesterday and some of the things that I mentioned in our activity when I last saw you in class. Now, we're going to start by reminding ourselves what a right angle is. Okay. A right angle is just anything that is 90 degrees exactly. An acute angle is less than 90 degrees. Less than 90 degrees. Oh, it's cute. It's a cute angle. It's so small. And an obtuse angle. An obtuse angle is one that is greater. Thank you. Greater than 90 degrees. Now, we've talked a few times about what an angle is, so hopefully you're feeling okay about that. An angle is just any time we take two line segments, or rays usually is the way they're represented, okay? And you're trying to measure what the distance is between the two of them. So if I start at 0, the lines are overlapping, the rays are overlapping. Let me move my hand. There we go. Okay. But then you can see how I'm getting more and more space. This pencil is moving away from the other one. Okay. We get to a right angle, and this is kind of what we're measuring everything against. When it was less than 90 degrees, it was acute. Here it's a right angle. There we go. There we go. And now we'll get down to an obtuse angle. Now, I almost went all the way and made it perfectly flat. If I do that, this is also a special kind of angle. When one of the rays has gone past 90 into obtuse all the way so that it's flat, this is what we call a straight angle. And a straight angle is exactly 180 degrees. Okay? So we've got these four major types of angles that we're talking about. 90 degrees, the right angle, probably our most important because at least the next two are measured off of that. Now if I take two right angles and put them together, I get a straight angle, 180 degrees. Just 90 plus 90, right? Now I want to take a look at a trapezoid that we're going to construct together. So this is where you'll need, again, I'm using a half sheet. You can use a whole sheet if you want. It's up to you. But please get that paper out now. Do the best you can to make sure it's a rectangle. Mine's not 100% perfect. Yours doesn't have to be either. But we want to start with a rectangle because I want two sides that are parallel to each other. Okay? I'm going to look at this long side here and this long side here as being parallel. If they were to continue on and on forever, they would never meet. Now, I am going to mark, let's say, right about here and right about here. If you're using lined paper, basically I'm just looking at where the pink margin line is here, and I can see the pink margin line through there. I'm going to take a ruler or some other straight edge. I'm going to go from that corner. I'm going to go right through that line. Okay. So it should look something like that. All right. I'm going to do the exact same thing over here. Go up to the corner, which honestly is not entirely there, but we'll We'll fake it. Should be okay. Doesn't have to be perfect for this demonstration. Okay. There we go. Now hopefully you can kind of see, maybe even a little more if I turn it this way, we have the beginnings of a trapezoid. I'm going to take some scissors. I'm going to take some scissors and I'm going to go ahead and cut this out. Boom, it's magic-ish. Alright, so now we have our trapezoid. We've got two parallel lines right here. These lines are not parallel. That's part of what makes it a trapezoid. But there's something else we're going to notice. And if you've got a protractor, you can go ahead and do this with me. Your numbers will probably be different. That's okay. But I'm going to go ahead. I'm going to put my little line right here at this vertex. I'm going to make sure the flat edge of the protractor lines up with this. And then it's nice. I just count from 0, 10, 20, 30, 40, 50, 60, 70. This crosses is about 75, 76. So I'm going to go ahead. This angle down here is about 76 degrees. Okay? 76 degrees. Again, yours may be different. I'll check this one over here. Probably going to be pretty similar, but we'll see. Now, technically the corner's gone, so I have to kind of eyeball it. Again, it's not going to be perfect. That's all right. Okay? We'll go over here to 0 and count up. 10, 20, 30, 40. I'm ignoring these numbers on the inside. 10, 20, 30, 40, 50, 60, 75, and 6 again. Yeah. About 76 degrees again. That's interesting. All right. Now, looking at the top. Okay. We can kind of tell already, this line sort of helps us. We can tell that this is probably going to be obtuse. It's probably going to be more than 90. So I'm going to zoom in a little bit. I've got to find the right spot for my protractor. Make sure it shows up on line. Again, you can see exactly 90 if I line it up, but it's a little far away, so I'll put that over here. Okay. All right. Starting again at the 0. Sorry, slide it up, make sure it's really clear. Starting at the 0. 10, 20, 30, 40, 50, 60, 70, 80, 90, more than 90. We're going over to about 100. Now, it might be hard to see on the computer, but this is 102, no, 101. 203. It's about 103, 104. Again, this corner's a little weird, so I'm going to round it up to about 104 degrees. Okay? 104 degrees. And there's a reason why I'm rounding it that way. I'm going to show you in just a moment. Okay. Let's measure the last one. Go ahead and measure the last one. Line it up. Start at 0. Okay. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That one's even more clearly on 104. Now, not every trapezoid is going to have angles like this that match every time. Okay? They're not always going to be opposite and match like that. But these ones do. I made something called an isosceles trapezoid. Don't worry too much about that. The connection I really want to look at is this way. And I want you to look back in your Learn book also for letter A, because we measured that one, and I want you to notice you've got one obtuse angle, one acute. One obtuse, one acute. When you add these together, 104 plus 76, you should get 180 degrees. And to be honest, that's kind of why I rounded the way that I did, is because with a trapezoid, when you take angles like this, consecutive angles that are on different parallel lines, and I'm going to say that a few times because it's kind of a lot to take in. Consecutive angles, so angles that are next to each other, consecutive angles that are on opposite parallel lines. See, 76 and 76 are consecutive, but they're on the same line. So it's not going to work. 104, 104. They're consecutive too, but they're on the same parallel. It's not going to work. These angles will add together to make 180. Now, mathematically, you can see why that works, but I'm going to show you something else. Here's my obtuse angle, right? My 104. Here's my acute angle, 76. I just tore that off. Remember, the angle is this measurement right here, right? 76 degrees. Look what happens if I turn this upside down and I take my 76 degrees, that's this part in here, and combine it with the 104, this part in here. Now, this paper's a little curved, so it's kind of hard to see, but check that out. Putting them together makes a straight line. 76 degrees plus 104 makes a straight angle. Okay. Try that out. See what you get. I'll give you a second to do it on your own. Even if you couldn't measure yours, even if you didn't have a protractor, if you take one of the acute angles and put it next to the obtuse, you should get 180 degrees. Let me show you something even crazier. Okay. Look what happens. I'm going to leave this one. But look what happens if I tear this and this. My poor trapezoid's in trouble here. But look, I'm going to put the 76 back here. That made a straight line. I'm going to put the 104 right there. Those two also line up and make a straight line. Look at that. Put it right there. Come on, off my finger. And then finally, if I slip in the 76 degrees, now this one's weird because it's torn, but if I kind of line it up, it makes a straight line, straight line. They all come together. All their corners point to each other. This would make a full, and again, the paper's torn, so it's not perfect, but this would actually make a complete 360 degrees. I can travel in a circle. 104 plus 76 is 180. 180 plus another 104, that's 284. Plus 76 gets me to 360, the full distance of a circle. All right, we're going to talk more about trapezoids specifically in class the next time I see you. We're also going to start taking some of this and applying it to different kinds of quadrilaterals later in the week. But for right now, go ahead, experiment with the paper a little bit. Throw it away when you're done. No real notes to take other than, again, this information, which should be included in other notes anyhow. But just want to try something a little different to expand on what we did in class. All right, ladies and gentlemen, if you have any questions or comments, as always, write them down, and I will see you in class. Thanks, everybody.